Done? Anybody else? This?
It's good. No. I'm not sure.
Yeah. Yo. Sure. Okay. Those of you that are done with your quiz, think about how you would simplify it. This one, done. That's what Dell's about 20 years left.
Oh, good.
Yes. Ventures, are you done?
Yeah,
No guess?
I forgot.
What opened 50 years ago in Seattle, Washington? Height is. It's Louis. What's that?
Oh, you said St. Louis. Well, I would have guessed if I were.
St. Louis. Is
Yeah.
that the mask?
The mask made Seattle sound like St. Louis. Yeah. That's right.
Really?
Yeah. Smelly Ellie, are you about done?
Yeah.
I mean, you have a lot of
I
stuff
don't
here.
really know how to do it, so.
Yeah.
I mean, you got a lot of work there. Starbucks.
I love it.
Starbucks. 50 years. It's a hard to believe, isn't it? Those two college kids from San Francisco, like, ever think they would just start something that would basically be in every corner of the globe? Not hard to believe it. And the company's worth ridiculous amounts of money. So did you figure out how to simplify? How would you simplify that? So Dell, I think you said what I think you said. Is that true? So those could cancel and it would just be 1 over 7 times 6 times 5 times 4? Okay. So we're going to learn the ratio test today. So tomorrow and Wednesday, like our little plan for that is we'll do it at 2. Because someone said we could go earlier than 2:30 to give you more time. I'll tape it or video it. And
What, community stuff?
I deserve. What? Did I say that right? At 2 o'clock?
Yeah.
So we'll do the same thing on Tuesday and Wednesday. And more than likely what we will do is I will go over the answers to the ratio test. Unless we don't get to everything I want to do today with the ratio test, then we'll start that and then start. So, yeah, so here we go. Let's talk about the ratio test. Woo, baby. Now, if you noticed in the Google, I also I'm going to hand you out a hard copy of this today. This is a summary of all of the tests. It's just great. Now, it's just so nicely organized. And I like the little comments about the thing, so I just copied this. There's actually a version of this in your book, but I copied this out of another book and wrote the law. So the ratio test says this. So like we're looking for an unknown series, right? Don't know what it does. So we're going to take this limit. Okay? We're going to take that limit, which is basically the n plus 1th term over the nth term. Okay? That's what that is. The n plus 1th term over the nth term. Which is essentially, when we're looking at a geometric series, when you think about a geometric series, the ratio of the terms is always the same thing. Well, what the ratio test is, it sort of softens the geometric test. It basically says, if the ratio of the terms isn't the same thing, but as long as it's less than 1. That's how it works, okay? So we're going to compute this limit, and we're going to say if L is less than 1, the series converges. Woohoo! If L is greater than 1, the series diverges. And actually, let's go back up here. It converges absolute. This is kind of kills 2 birds with 1 stone. And so I have if L is less than 1, L is greater than 1. What's the other option? If L equals 1, test fails. And that gets a sad face. Okay, so that's the ratio test in a nutshell. The hard part about the ratio test is just doing the algebra of figuring out what the ratio of those terms are. Okay, so we're going to do some examples to give you some insight on that. Okay, so I made up 3 this morning. Okay, so there's our first one. That's n times 2/3 to the n. All right, so we're going to do the ratio test. So I'm going to look at this limit. So I need an expression for what does the n plus 1 term look like. Very simple to do. You just take where you see the expression for n, and everywhere you see an n, you put n plus 1. Okay? So it'll be like this. N plus 1 times 2/3 to the n plus 1 over, so that's the n plus 1 term, the nth term, which is just n times 2/3 to the n. Okay? And then you just put on your algebra pants and you simplify this. Okay? So what happens when I simplify this? 2/3 to the n plus 1, 2/3 to the n. How does that simplify? Subtract the exponents and you're just left with 2/3. And n plus 1 and n don't simplify, right? Those are just hang out. Now this 2/3, since it's just 2/3 and doesn't have an n in it, I can take it outside the limit and I'm there. Okay, so now I'm going to compute this. As n goes to infinity, what is this approaching? This p right here. 1, right? So this is 2/3 times 1, which is 2/3. Is that less than 1? Yep. So the series converges. Woo! We'll put a smiley face with that. All right, let's do another one. Is that scary? This one's going to seem scary. Promise, though. We can do it. 2 to the 2n plus 1 times -1 to the n over 2n plus 1 factorial. Okay, so ready to set up the ratio test? So we need the n plus 1th term, right? So everywhere we see an n, what are we going to plug in? N plus 1. 2 to the 2 times n plus 1 plus 1, negative 1 to the n plus 1, over 2 times n plus 1 plus 1 factorial. And then all that's going to be divided by 2 to the 2n plus 1, negative 1 to the n, divided by 2n plus 1 factorial. Yuck. That's a big yuck, right? It's a nasty one. My recommendation, when I do the rest of the ratio tests, I almost always, instead of writing the fraction, I do the n plus 1th term times the reciprocal of the nth term. I just set it up that way. It's so much easier to clean up. Do you see how this is just a hot mess, right? So let's go ahead and do that now. So while I'm at it, I'm going to do some simplifying here. That's 2 to the 2n plus 2 plus 1 is 2n plus 3. Negative 1 to the n plus 1 over 2n plus 3 factorial. And then the reciprocal of the nth term is going to be 2n plus 1 factorial over 2 to the 2n plus 1, negative 1 to the n. Now, for some reason, that just looks cleaner. It looks easier to work with. Okay? Now, first thing that we have to talk about, the absolute value and the negative ones. What can you do with those negative ones since it's inside the absolute value? Just don't, it's chuck them. Just forget they're even there. Okay? Since we're inside the absolute value here, these negative ones just don't even worry about. Okay? Now, how can I simplify 2 to the 2n plus 3 and 2 to the 2n plus 1? What's that going to end up being? You really got to have on your algebra pants here. 2 to the 2n plus 3, you subtract the exponents. So what are you going to have left? 2 squared or 4, right? 2 to the 2. 2n plus 3 minus 2n plus 1 is 2 squared. Oh, baby. How am I going to simplify this? 2n plus 1 factorial over 2n plus 3 factorial. Well, 10 minutes ago, Abdel simplified something very similar to this on the board over there, but we had numbers in it. 2n plus 3 factorial is the same thing as 2n plus 3 times 2n plus 2, because you go down by 1, times 2n plus 1 factorial. It's like the exact same thing that Abdel did, just in terms of n's. So what's going to happen to these guys? Those are going to cancel. And we'll go up here now. So the limit as n goes to infinity of 2 squared over 2n plus 3 times 2n plus 2. And what's that limit? Zero. Yeah? The 2 squared is meaningless, right? So this limit is 0. What's our conclusion? Well, 0 is less than 1. So the series converges by the ratio test. Okay? I I can tell you where kids struggle with this. It's right here. This is the thing that people like get all worked up about. Because this is a new idea for you. Like this idea of writing 2n plus 3 factorial, writing that out as an expression in terms of n, that's new. You're not, I mean, the factorial thing was kind of new for you 3 weeks ago, right? So this is where it gets weird. I just have to tell you, like when you do this, you just count down by 1 until you get the 1 on the numerator. That's what we did here. I mean, that's what Abdel did, right? That's where it gets goofy. Other questions on that? We're going to do another one. Is the ratio test pretty easy to do? As long as if you are wearing your outfit pants and they're fitting properly. It's not too bad. But again, here's another example of where you're going to be computing a limit, and you have to know what the answer to the limit is, and then what do you conclude by it. You know, what does this 0 mean? Like in this context, this 0 that you got, what does that mean about this series? Yeah, it converges, but what does the 0 actually mean? It's kind of funny how you can actually draw the conclusion that the series converges based on that 0, but we don't know what the 0 actually means. That 0 is just saying that the ratio of the terms is approaching 0. The ratio of the terms is approaching 0. That's what that's saying. Right? And if that's true, you would think, oh, yeah, that would make sense that it would converge. Right? All right, let's do one more. This is just to give us some more factorial practice. Whoa! By the way, 0 factorial is defined to be 1. I'll show you why. So this series could start at 0. Okay, so set up the ratio test. You guys set it up. And I'm going to do the reciprocal of the nth term instead of the division. Try to set it up and see if you do it right. So if you put divided by n factorial over 2n factorial, that's correct. But if you want, you can just jump right to this step. That's totally fine. Okay, I will tell you the parentheses are huge. Because like this is 2n factorial, right? So when we plug in n plus 1, it needs to be 2 times n plus 1, not 2n plus 1. There's a big difference there. All right, so let's simplify. Let's simplify. So now I'm going to simplify these factorials. That's n plus 1 times n factorial. That's 2n factorial. This one here is 2n plus 2 times 2n plus 1 times 2n factorial times n factorial. Look how this is going to just all come out nice and cute. Okay, who gets canceled here? So we're left with n plus 1 over 2n plus 2 times 2n plus 1. I think. What's that limit? You. And what does that mean? That's less than 1. So the series converges. So what happens if it equals 1? When you do the ratio test, what do you have to do? You have to do something else. Or just throw in the towel. Just give up. Call in sick. Okay, so here's our ratio test problems. So start working on these. We'll go over these tomorrow. I would recommend that you jump on this early because we're having a test on Friday, right? The ratio test will be on that test. If you choose to not look at the ratio test and sort of mess around with that until Wednesday or Thursday, that could be bad for you, right? I mean, you want to make sure you have that all squared away.
The test is Friday, not Thursday.
The test is Friday, yeah. I'm not going to be here on Friday, so 50-50 became 100.
You're gonna leave the sub a bonus?
Yeah, I will. And if you want one of these summaries, you can get one of those today, or I can give it to you tomorrow too. I also put it on the Google. But I made it purple so it would stand out. You can grab one of these on your way out. Anybody want one?
Yeah.
They're really nice. I mean, they're, whoa, look that up. For you. For you. For you. For you. Yes. What? Are you sure? I think you did it right.
I don't think I did it right. Because all the ones that I was, the ones that I was like, yeah. I was wondering why you were asking. Yeah.
You did that right. You did it all right. What, Shelby? I don't think so. You're taking it on, it's like the end of May, right? I'm going to give you something. This is, now the format of the test is a little different than what's in this. This is two multiple choice sections, one with a calculator, one without. And actually it's the other way around, one without and one with. Then this is 3 free response with the calculator and 3 free response without a calculator. The new format, and I think since you're taking it at the end of May, it's not an adjusted format, it's like the regular format. So the format that you'll have is going to be multiple choice, same thing, but the free responses, you'll have 4 without a calculator and 2 with a calculator. Does that make sense? On half of, there are 25, or 28 multiple choice questions without a calculator and 17 with. So it's a little less than half you get a calculator. But you'll see what they look, the ones with the calculator are very different. And do you have a graphing calculator?
Yeah.
That's a very common thing. And some of the questions on the calculator section, they cannot be done without a calculator. You have to. So that's that. So like this is 5 practice tests. Like these are, when I was teaching AP, I found that these practice tests were some of the best. Like they were the most authentic. They looked like a real test. Now the test is different every year, so but you can have this. This is the answers. You can just have that. So if you want to just write in that, you can. I would recommend like starting to look through some of that. If you get to a problem that you don't know how to do, let me know. Because between now and then, I can probably teach you how to do that. So, I mean, you just never miss anything, so I'm not worried about it. What's that?
The material.
Most of the content is the same. Now, some of the difference is just some of the wording, like the way problems are framed and presented to you are just different. And because this isn't AP, like I haven't been teaching you that way all year long. Like that's why I'm giving that to you now, so you can start to look. But you've got plenty of time. I think you'll be okay.
Yeah.
So. What day is your exam? Oh. What do you want to know that?
You said that we were thinking it like before the senior stuff. Or was that wrong?
Before the seniors leave? No, before they graduate. More than likely, it's going to be the day before. So like the 19th. Because I'm thinking.
Well, because it'll just be before exam.
Yeah, way before exam.
That's fine.
Yeah.
That's all I wanted to know.
I mean, we're gonna have pizza parties in here. You know what I mean? Like,
Did you guys go fishing?
You're gonna bring a little baby pool.
Yeah. And I'm hoping, I think that if all goes well, that I don't think that the seniors will have to come in all of those days after their last day before their exam. I think I'm going to be able to make it so that we can only have them come in. You know, they get out on a Friday and their graduation is like 2 weeks later, almost 2 weeks later. I don't think they'll have to come in all this time. I'm trying to make that happen. That's one of the reasons why we have to do tomorrow. It's like, yeah. 2:30 tomorrow or Wednesday. Or 2 o'clock, sorry, tomorrow or Wednesday. Either one. Huh? You choose whichever one you want to come to.
Yeah, it's gonna be from what time to what time?
Like we'll meet at 2 here.
Okay.
Yeah. Is the bell run? You guys want to start your quiz? Oh wait. Did anybody ever sit here? How was your games?
Well, see, if we were in the division that we originally put in, we would have won. And then our coach just moved us up 5 divisions.
No.
So we're in the top 200 in the nation, elimination. So we lost 2 games and we won.
So that's pretty good.
Yeah, we did.
So your bonus question. What opened its doors 50 years ago last month in the Pike Market in Seattle, Washington?
Oh.
What opened
I
its
know.
doors 50 years ago last March 30th, 1971, in the Pike Market in Seattle, Washington? This is, you've been there?
I've been there.
Well, you probably went to this place.
Have the best fruit I've ever had.
That is where they throw all the fish around, you know. And you can use any test you want. Just after number 6, you have to tell me if it's absolute or conditional. Yeah, you can use your previous answer. I kind of did that intentionally. Although half the kids last period didn't catch it. Oh I think.
I didn't know.
So when you're done with your quiz, I want you to think about how you would simplify this.
Not actively, like, I did. Just, no, just depends. Where I go. Like, no, there's scary stuff. The
Scary drama.
well, we sent it to the pictures on Friday, and they sent it back to us and took the pictures with you all, like the resolution tonight. So it released wants us to like change it, but none of us know how. So I have to go under to like figure it out.
Sometimes it's better. the only thing I can do.
It's a good guess.
Yeah. Yeah, I didn't get it.
Definitely not. Like, I can tell you guys my guess, and it wouldn't hinder me.
I guess what was in did you know there's a carry that I know and stuff?
What?
A carry park. And spelled the same way.
Carry what?
Park.
Carry what? Oh. Spell your spell.
I'm not on the right track for the one street, I completely not.
Not even close. It starts with the same letter. Billy, are you going to be the only one to get it?
Yeah.
Did you get it?
That's the only way to do it. Does it invent it?
Well, the crazy thing is you've been there and you don't know it. Starbucks.
Oh.
Yeah, I would never get that.
I didn't go in there, but I saw
What
it.
did you get?
It was
I
very
said
busy.
fish shop.
And the interesting thing is if you go to Starbucks now, one of their coffees is Pike Place Roast or whatever.
Man,
That is what it is.
Okay, so we're going to learn the ratio test today. I also am going to give you this paper here, which I put on the Google. This, but here, if you get it live, you get a hard copy. It's purple. This is a summary of all the tests. And I normally don't do this, but I just really like how this is organized. And it's very nice. And I really like the comments here. So, yeah, I'll do that before you leave. Also give you this homework for the ratio test. More than likely how tomorrow or Wednesday will go down is we'll probably just go over these homework problems. All right? But I would recommend, we're going to learn the ratio test here today, but I would recommend that you not wait until Wednesday to start trying to figure out the ratio test. Because it's going to be on your test on Friday. And if you don't do anything with the ratio test between now and then, like, it's just going to make your life a lot more complicated. So, yeah. You ready to learn the ratio test? Not to be confused with the Horatio, which is a character in Hamlet. Right? Horatio? That's Mercutio.
Oh, yeah.
I think Horatio is in Hamlet.
Yes, it is.
He gets killed and he says, "I'm dead, Horatio."
Yeah, Gavin just didn't actually read Hamlet.
Oh, you didn't read it? Oh, well,
I
then
read summaries.
that's not going to make it funny then. So we'll just call it the ratio test. Okay, so how the ratio test works is you guys know the geometric series, right? What's the rule for geometric series? The common ratio has to be less than 1, right? That's how the geometric series test works. Okay, the ratio test is just basically kind of a softer version of that. It looks at any series and just says, okay, well, if the ratio of the terms is approaching something less than 1, your series is going to converge. Okay? So it really softens the geometric thing. It doesn't have to be, it just basically looks at everything and says, okay, they're geometric. Or they treat them like geometric.
Like, whatever n approaches less than 1 is 0.
No, the ratio of the terms, not the terms themselves. You'll see what I mean in a second. So the ratio test looks like this. You're going to take the limit as n goes to infinity I guess we're starting off with an unknown series here. I didn't write that down. Okay? You're going to take the ratio, the limit as n goes to infinity of the ratio of the n plus 1th term over the nth term. And it's going to be the absolute value of that. Okay? So you're going to compute that limit. And then you're going to interpret the answer. Okay? So we're going to say if this limit equals L, okay? 3 options. 1, if L is less than 1, the series converges and is actually absolute. Because this absolute value thing here takes care of that. Number 2, if L is greater than 1, the series diverges. Okay? So what's our third option? If it equals 1. If L equals 1, the test fails. And that's a sad face. Yeah.
So if this test fails,
Then you got to use another one. Okay? So the difficult part about this, about the ratio test, is you really have to make sure you have on some good fitting algebra pants. Because there's some algebra in this, all right? You have to find an expression for the n plus 1th term. Sometimes that's complicated to do, or tricky. Yeah.
So if L equals 1, does that mean the series is just has the same term over and over and over?
It means that the ratio, no. It means that the ratio of the terms is approaching 1, which could indicate that. Okay? But it's not necessarily mean that the terms are approaching the same number. Okay? You'll see, when we get through these other examples, I'll do one like that to show you. Okay, so let's bust out a couple examples here. So here's our first one. N times 2/3 to the n. N times 2/3 to the n. Okay? So we're going to use the ratio test here. And so we have to set up this ratio here of the n plus 1th term divided by the nth term. Really, this should be n plus 1, like that. So the way you do that is you take the expression involving n, and everywhere that you see an n, you just put n plus 1. Okay? So this will be n plus 1 times 2/3 to the n plus 1. Okay, so that's the n plus 1th term. And then we're going to divide that by what? The regular term. And then we're going to do some algebra. We're going to simplify this to compute this limit. Well, what happens to the 2/3? You have 2/3 to the n plus 1 and 2/3 to the n in the denominator. How does that simplify? 2/3 to the 1, because you subtract the exponents. And if you want, you can take that 2/3 outside of the limit. And you get this. And what is that limit there as n goes to infinity? What does this equal? Oh, that was my fault. Sorry about that. I flipped it by accident. So what is the limit as n goes to infinity of this? You sure? Isn't it just 1 times 2/3? So the answer here is 2/3. Okay. Well, 2/3. Hey, that's less than 1, so the series converges. Right? Now, what does the 2/3 mean? Okay, the ratio test is real easy to take the 2/3 and make the conclusion, but realistically, what does the 2/3 mean?
As n approaches infinity, each term will be 2/3 of the previous term above approaching that ratio.
Right. So I was just, you said it actually probably a little bit more eloquently than I was thinking. The ratio of the terms is approaching 2/3. Each term, as n gets bigger and bigger and bigger, each term is going to approach being 2/3 of the previous term. So like if the limit was 1, it would be like saying each term is 1 times the previous one. So it's like the terms are sort of approaching the same number. But that's really why I guess the test fails, because the only way that could potentially work is if that ratio, if the terms were also approaching 0 at the same time. Okay. All right, let's do another one. You ready? So you ready? We're going to set up the ratio test. So now, every place we see an n, we're going to plug in n plus 1. Now, parentheses are very important here. Like, for example, right here, 2 to the 2n plus 1 plus 1. Okay? That's got to be there. It's not 2n plus 1 plus 1. You get the difference? Negative 1 to the n plus 1 over 2n plus 1 plus 1 factorial. So there's the n plus 1th term. Now what's the nth term look like? Just copy it down. Okay, that looks like a hot mess. Yeah.
Why does the 2 to 2n plus 1 turn into that as opposed to just 2 to 2n plus 2?
Because when you plug in, it's 2n plus 1, right? So if I want to plug in the n plus 1 term, and I'm going to plug in, if I'm going to evaluate this at n plus 1, then this needs to be 2 times n plus 1 plus 1. Okay? That's a hot mess. All right? I mean, it's ugly as sin. I would recommend, and this is how I do it, rather than making that big complicated fraction, I actually will start the problem off this way. I will take the n plus 1th term. Let's go ahead and simplify that. That's going to be 2n plus 3. And then multiply by the reciprocal of the nth term. That's the same as dividing, right? So when I multiply by the reciprocal of the nth term, this just looks a little bit cleaner to deal with. It looks less intimidating. It's still intimidating. All right. Now, one thing that's nice about the ratio test is since we're absolute valuing these, right? These negative ones mean nothing, right? Just doesn't mean anything. So once you're inside these absolute values, you can pretty much just get rid of that because they don't mean anything. So now we want to simplify 2 to the 2n plus 3 times 2n plus 1 factorial over 2n plus 3 factorial 2 to the 2n plus 1. Let's do the 2's first. How does 2 to the 2n plus 3 and 2 to the 2n plus 1 simplify? Alex, how does it simplify?
Just 2.
Try again. Subtract the exponents. Isn't it 2 to the 2? Isn't it 2 to the 2?
Yeah. Is that not what I said? Is that 2?
I said, how does it simplify? You said 2.
Oh, okay.
It should be 2 to the 2.
The
I think you're just giving me the exponent. Okay, gotcha. So that's 2 to the 2, right? I'm going to just go ahead and take the 2 to the 2 out of there. Just to get it nice and clean. And now we're there. And now we're going to simplify these factorials. Okay? So I'm going to hit the pause button right here. And I'm going to go over here, and we're going to go back to this factorial that I asked you to simplify when you were done with your quiz. If you simplified this, 3 factorial and 7 factorial, 7 factorial is 7 times 6 times 5 times 4 times 3 factorial, right? Isn't that what 7 factorial is? It's 7 times 6 times 5 times 4 times 3 times 2 times 1, but 3 times 2 times 1 is really 3 factorial. So these guys could cancel, and you'd be just left with 1 over 7 times 6 times 5 times 4, right? How is this going to simplify? Well, 2n plus 3 factorial is the same as 2n plus 3, and now go down by 1. What's the next one? 2n plus 2. Oh, 2n plus 1 factorial. So those guys cancel. So we're left with 2 squared times the limit as n goes to infinity of 1 over 2n plus 3 times 2n plus 2. What do we get? Well, as n goes to infinity, that part's going to 0. So that's 2 squared times 0, which is 0, which is less than 1, so the series converges. So the hard part about this is setting up that n plus 1th term over to the nth term, and then simplifying the factorials. Okay, kids struggle with that because that's a new thing to you. You're going to do that before, right? That's why we're going to do another one with simplifying factorials. Whoops. Here's our last series for the day. So you might look at that and think, whoa, how can you start that at n equals 0? Okay, 0 factorial is equal to 1 by definition. I'll show you why that is tomorrow. Okay. It kind of has to be equal to 1, otherwise factorial, the pattern won't work. All right, so see if you can set up the ratio test. The ratio of the n plus 1 term divided by the nth term. I would do the n plus 1 term times the reciprocal of the nth term. See if you can do it without me. That's what you get when you set it up. So now I'm going to simplify it. The numerator is and the denominator is 2n plus 2 times 2n plus 1 times 2n factorial. Look at all the canceling that you get to do. N factorial, 2n factorial, 2n factorial. So you're basically left with this. And what's that limit? Oh, question.
How do you get the n plus 1 times
N plus 1 factorial. Right, n plus 1 factorial is n plus 1 times n factorial.
Oh.
So how does that simplify? Or what's the answer to the limit? 0. Because that's big time bottom heavy, right? And 0 is less than 1, so this guy converges. Right? Okay, so our ratio homework. This. And then, if you want to take one of those test summary papers, you can grab one of those. I'll see you tomorrow or Wednesday or never.
Maybe tell you which day will come.
No. Because I think it'll be, I think we'll have enough room no matter what.
One guy shows up on
What? Tomorrow or Wednesday, 2 o'clock.
they are good.